Okay, this is section 2.2. We're going to be doing a little bit of arithmetic with functions. So if you give me two functions, f and g, I can make new functions out of these two. So f is a function and it has a domain. G is some other function, it also has its own domain. We can come up with a new function called f plus g of x. And the way f plus g of x works is that it's just f of x plus g of x. It's a new function. It has a new domain too. F minus g of x, well, it's just f of x minus g of x. F times g of x is just f of x times g of x. And f divided by g of x is f of x divided by g of x. But again, we do not want to divide by 0, so just make sure that that g of x is not equal to 0. So from two functions, f and g, we can create this other four new functions: the sum, difference, the product, and the quotient. Okay, what about the domains of these functions? Let's think about that here for a second. So if f and g are functions, then the domain of the sum, the difference, the product is the intersection. So the intersection means the overlap of the domains of f and g. So keep that in mind. So if you start with two functions f and g, you can create the sum, the difference, the product. The domain of those three new functions is just the intersection of the domains of the two original ones. The domain of the quotient is also the intersection of the domains of the two original ones, except that we want to be careful and not divide by 0. So we're also going to have to exclude from the intersection any values of x for which g of x is 0. Alright, so let's put these ideas to work. Here, I guess you will always, so for instance, if you start with two functions, you will always end up with a smaller domain, or the smaller domain of the two functions as the domain of your new created function. So let's use this. So here we have an example. We were given two functions. One of them is f of x, which is just x plus 1, and we have another function, the square root of x plus 3. Okay, so let me just kind of, first of all, before I get into any of these examples, so I mean, here at this point we're going to have to answer these three parts. But before I get into answering any of these parts, let me just think about what is the domain of f of x. So we have f of x, and it's x plus 1. Its domain. So its domain. What's the domain of this function? I would say that it's everything, negative infinity to positive infinity. Let me think about the domain of my function g of x. The domain in this case, so remember, right now what we're trying to avoid is we do not want to have negatives inside of the square root. So one thing we could do to find the domain is set this inequality up. In the last section, this is what we did. So we could set this little inequality up and then just kind of start working. So this would say that it's x's that are bigger than negative 3. So things that are, actually in this case we can do bigger than or equal to 0. Why? Because the square root of 0 is just 0, so that's okay. So I want x plus 3 to be bigger than or equal to 0, so then that means that x is bigger than or equal to negative 3. So then that means the domain is from negative 3 to positive infinity. Okay, the reason why I'm mentioning the domains of the two original functions is because we're going to need them here in a second. Okay, so at this point, if I was you, I would just pause the video and try to answer these three things. One of them is compute this new function, f plus g of x. What's the domain of that function? And then we have to do f plus g of 6. Okay, so hopefully you went ahead. You already kind of have answers for these three little scenarios. And let's just compare our answers then. So let me begin with part A. I know that this is supposed to be equal to f of x plus g of x. Yeah, that's just by the definition that they gave us up here. So f plus g of x is just equal to f of x plus g of x. Okay, so well then, let me just continue here. So the f of x is just x plus 1, and then plus, and then my function g of x is the square root of x plus 3. And it's, I guess that's all there is to do here. I mean, if I could collect like terms, if there were some other constants that I could combine with constants or x's with x's, I would do so. But in this case, there really isn't much to do here. There is not too much to do here. I'm just, that is, I guess, as far as we can take that. So that's our first answer there. Okay. So we started with these two functions, f of x and g of x. We created a new function, f plus g of x. Great. What's the domain of this new function? What's the domain of this new function? Well, according to our little guideline up here, the domain of the sum is just the intersection of the domains of f and the domain of g, of the two original ones. That's why we found the domains of the two original ones earlier. We said that the domain of f of x was negative infinity to positive infinity. The domain of g of x is from negative 3 to positive infinity. Okay, so then that means that the domain of the sum, this new function that we just came up with, should be the overlap of these two sets, the intersection of these two sets. What's the intersection of these two sets? So let's see. You can think about it like this. So the domain of f of x is absolutely everything. It's negative infinity to positive infinity. So all the way from the left to all the way to the right. That was negative infinity to positive infinity. The domain of g of x is from negative 3 to positive infinity. This is the domain of g of x, from negative 3 to positive infinity. And now you gotta think, okay, where do these two sets overlap? What's the overlap of these two sets? And well, it looks to me as though the overlap is, it's actually the smaller set, negative 3 to positive infinity. That is, I think, the overlap, yeah? So I'm going to conclude here then that the domain of the sum is negative 3 to positive infinity. So that's what we mean by the intersection of the two domains. So the domain of our function f of x was everything, every single real number. The domain of our function g of x is everything from negative 3 to positive infinity, including negative 3. And so then the overlap of those two sets is just the smaller of the two sets. So hopefully you're okay with this idea of the intersection of two sets. Okay, and finally, let's answer the last part. For the last part, we're supposed to just end up with a number. So one thing we could do, so f plus g of 6, we already have a formula for f plus g of x. That's what we did up here in part A. We could just plug 6 into that new formula. So that would say 6 plus 1 plus the square root of 6 plus 3. And well, then that says that that's 7 plus the square root of 9. And so then that's 7 plus, let me just go vertically here. That's just 7 plus 3, which I guess we end up with 10. That's our answer there. That's one way to do this. That's one way to do this. Another way to have done this, maybe you did it this way, I don't know, is to have done the following. It's going to be f of 6 plus g of 6. Yeah, and well, f of 6 ends up being 7, and g of 6 ends up being the square root of 9, which is 3, and so our answer is 10. Yeah, so we could have also done it that way. Okay, good. Let's move on to the next example here. This guy has a lot more parts, and that's okay. So what we're going to have to do, so we were given two functions, f of x, which is x minus 2, and h of x, which is x squared plus 1. Yeah. And if you think about it right now, just sort of let's just for reference think about what are the domains of our original functions. So for f of x, I'm going to say that the domain is negative infinity to positive infinity. Yeah, that's domain for my top function up here. For h of x, it's the same thing. For h of x, my domain is also negative infinity to positive infinity. Okay, so just keep those in mind, because they're going to ask you to find the domain of some other functions. So we were given two functions whose domain is all real numbers, and now we want to find, we want to compute these new functions, f plus g of x, f minus h of x, f times h of x, f divided by h of x, and state the domain of each of these new functions. Okay, so pause the video, take a few minutes. This is going to require a few minutes because it's 6 little exercises, and see if you are successful at coming up with some answers here. All right, so hopefully you did get a chance to work this out and you have some solutions, and let's just compare our answers then. So for this one, let's see, let's compute this. So this is going to become f of x plus h of x. Okay, so then this becomes x minus 2 plus, and then it's going to be, I mean, technically here I should put a parentheses just to be careful. It's x squared plus 1, yeah, because this positive right here is going to affect everything that my function h of x is. And well, right now there technically here there is like this sort of 1 right here. It's plus 1, and I have to distribute a 1. It's kind of not as important in this particular scenario, but in the next one it'll be a little bit more important. So let's see, so plus 1. So let me collect like terms here. X squared should be added or subtracted to x squareds. X should be added or subtracted to x, and numbers should be added and subtracted with numbers. And I'm going to write this in descending order. So this becomes x squared plus x, and then minus 1. See, because x squared, I just put it on the left. This positive x, well, it's right here in the middle. And then negative 2 plus 1, that's negative 1. That's how I conclude that, yeah? And it looks to me that the domain in this case is supposed to be the intersection, is supposed to be the overlap of the domains of the original functions. And remember, we have the domains of the original functions up here on the left corner. And so what's the intersection? What's the overlap of these two domains? Well, I would say it's the same domain. It's negative infinity to positive infinity. So I'm going to say that the overlap of those two domains is, well, still negative infinity to positive infinity. Okay, so that's our answer for the first part. Hopefully we agree on that. Next one, let's see. So this becomes f of x minus g of x. Yeah. Okay. So similar to the previous exercise we did. So this is going to become x minus 2 minus, now this parentheses here that I'm going to put is sort of important because it's going to change the signs of my function h of x. So earlier in the previous example I also used that parentheses and it wasn't as important, but I'm just going to get in the habit of using this just to be careful. So x minus 2 minus, I open a parentheses, and then this is x squared plus 1. Okay, so then this becomes x minus 2 minus x squared minus 1. And I'm going to collect like terms and write this in descending order as well. So negative x squared plus x, and then in this case it's going to become minus 3. So the negative x squared just went to the leftmost. This positive x is now in the middle, and negative 2 minus 1 is negative 3. By the way, this is called descending order because we're thinking about the exponents. So it's descending order of exponents. The exponent, so the term with the largest exponent is in the leftmost. So in this case, the exponent is 2. And then the next highest exponent, I guess here there's an exponent, even though it doesn't appear to have one there, the exponent is 1. And here, technically, there's still an x. It would be just x to the 0 power, because anything to the 0 power is 1. So that's why it's called descending order. And you don't have to write it in descending order, but it just makes things prettier. Good. So now let's answer the question. What's the domain here? What's the domain of this one? Well, it's similar to the previous one. It's just going to be the intersection, the overlap of the domains of the original functions that you started with. And well, the domains are negative infinity to positive infinity, negative infinity to positive infinity. So then the overlap is going to be the same, negative infinity to positive infinity. Okay, so hopefully so far so good. Let's get into the next examples here. Now I gotta do multiplication. So let's see. Okay, so f times h of x. Well, that just means f of x times h of x. Okay? And so then I'm gonna use parentheses because now we're dealing with multiplication. So this becomes x minus 2 times x squared plus 1. And now you gotta think FOIL here. We gotta do x times x squared. That's gonna be x to the third. And then x times 1. That's x. So we're done with x. Now we distribute negative 2. Negative 2 times x squared. And then negative 2 times 1. Yeah, that's how we're going to multiply this. So x cubed plus x minus 2x squared minus 2. Yeah. Now let me just rewrite it in descending order here. So x cubed minus 2x squared plus x minus 2. So that's my new function. It's the product of the two original ones. And what's the domain here? Well, again, I think it's similar to the other two exercises that we've done. The domain is going to be from negative infinity to positive infinity. Because it's just the overlap, it's just the intersection of the original domains of our functions. All right, next one. Let's see. Here I think the domain is going to start getting a little bit more interesting. So let's get into this part D. So this is f of x divided by h of x. Okay, so that's x squared minus 2 divided by, oops, it's not x squared minus 2, I'm sorry, it's just x minus 2 divided by x squared plus 1. Okay, so now with division, determining the domain gets a little bit more interesting. So let me just kind of remind myself, what is it that our notes say about figuring out the domain of a quotient? So the domain of the fraction f over g is also the intersection of the domain. So it's also the overlap of the domains of f and g. But then we need to exclude any values of x for which the denominator is 0. So we need to exclude any values of x that make our denominator 0. All right, so here the domain of this function then is going to be the intersection of f and h, which is going to be negative infinity to positive infinity. But then we have to exclude any values of x that make the denominator 0. What values of x make this denominator 0? And so, I mean, one way to find out is to set the denominator equal to 0. Yeah, and if we were to solve this equation, we would end up with this, x squared equals negative 1, and then if we take the square root, then we would have plus or minus square root of negative 1, which maybe you've heard about, maybe you haven't, but that's called a complex number. Yeah. So there are some complex numbers. There's a pair of complex numbers that make our denominator equal to 0. But right now we're not interested in complex numbers. We are looking for real numbers that make the denominator 0. Well, it turns out that there aren't any. X squared plus 1 never hits the x-axis. That's another way to think about it. This is a parabola that's been shifted up 1 unit. It never hits the x-axis, so there are no values of x for which the denominator will be 0. So then the domain of this function is just the intersection of the domains of the original ones. And well, the domains of the original ones were negative infinity to positive infinity. So the intersection is just negative infinity to positive infinity. All right, let's see. Let's try the next one. Then in the next exercise, you're just supposed to end up with a value. This is just supposed to be a number. This is just a number. I kind of want to change the problem a little bit. We can do both. So let's see. Let me just do the first one first. So h divided by f of 2, well, that just means h of 2 divided by f of 2. And then we just got to do some arithmetic here. Then it's just a little bit of arithmetic. This is going to become 2 squared plus 1 divided by 2 minus 2. Yeah? Okay. So let's see, what do we get? So we're going to get, this is going to become 5 divided by 0. So this is undefined. This is undefined. Yeah. Let's see. Let's just take a tiny little detour. What if we actually wanted to find this function, h of f of x, and we also want to find the domain of this new function? All right. So I'm going to then conclude that this is going to be h of x divided by f of x. And well, that's going to become x squared plus 1 divided by x minus 2. And now, what would be the domain of this new function here? Well, the domain is going to be the intersection of the domains of the original two, which is everything negative infinity to positive infinity. But then we have to exclude any values of x that make this denominator 0. And what values of x make this denominator 0? I would say positive 2. So think of all the real numbers, but then you have to get rid of positive 2. So then I think my domain ends up becoming negative infinity to 2, parentheses, union 2 to infinity. Because I need to use parentheses because I cannot include 2. Alright, so here we kind of did a few things extra, but that's okay. Just a little bit of extra practice, never hurt anybody. Let's conclude the last two. So let's see, let's do f times f of x. So f times f of x. So that just says x, well, let me write it like this. That would say f of x times f of x. That's what it means. And well, f of x is just x minus 2, so that's x minus 2 times x minus 2. And if you FOIL this, this should become x squared minus 4x plus 4. And the domain is going to be negative infinity to positive infinity. Yeah. Last one, h minus h of x. Well, that just means h of x minus h of x. And our h of x is x squared minus 1, or x squared plus 1, sorry. Oops. X squared minus, and then I'm going to say x squared plus 1. Okay? And I have to then distribute this negative. I got to distribute this little negative. So this becomes x squared plus 1 minus x squared minus 1. And so if you think about it, everything cancels here. All sorts of things are going to cancel for us. So I end up with 0. What type of a function is this? This is the function y equals 0. Well, that's just the x-axis. That's just our x-axis. That's what the graph of it looks like. And the domain turns out is also from negative infinity to positive infinity. Okay, so hopefully we were on the same page when it comes to determining these new functions and also determining their domains. Good. Let's move on to this other example. Now we're going to think about these ideas graphically. All right, so what you have been given here is two functions. You were given a function f and a function g. Your function f is this blue lower line. That's our function f. Our function g is the top green line. Yeah? They're functions, they pass the vertical line test. Okay, so pause the video, see if you can come up with answers for these 4 parts right here. Find the domain of f, find the domain of g, find the domain of f plus g, and find the domain of g divided by f. Okay, so hopefully you have found all of these domains. Let's compare answers then. What's the domain of f? Remember, the domain is pertains to x-axis, or x values. So you're thinking left to right. So my function f goes as far left as 0 and as far right as 9, I would say. And the endpoints are included because they're little solid dots. So I'm going to be using brackets. So I'm going to say that the domain of f is 0 to 9. Yeah? The domain of g looks to me as it is 3 to 10 inclusive. So, oops, that's a weird little bracket. It's okay, we can do better than that. So 3 to 10. Okay. What's the domain of the sum of these two functions? And I mean, we could try to visualize the sum based on the pictures of the other ones, but that's going to get a little weird. So we know that the domain of the sum, difference, and product is just the intersection. It's just the overlap. It's just the overlap of the domains of the original functions. So what's the overlap of the domains of the original functions? So one domain is from 0 to 9. The other domain is from 3 to 10. Where do those two sets overlap? Would you agree that they overlap in between 3 and 9? That's where those two things have an overlap, 3 to 9. And it's inclusive. So that is the domain of f plus g. So hopefully you agree on that. Now the next one, the domain of g divided by f. Well, it turns out that the domain of g divided by f is also the intersection, the overlap of the domains of the original ones. So the domain of g over f is similar to the domain of f plus g, except that we need to get rid of any values that make f, any x values. We need to get rid of any x values that make f 0. And well, let's see, let's look at the function f. When is it equal to 0? When is the y equal to 0? So here it's 2, it goes up. Right here at 6, my y value is 0. And right here at 8, at x equals 8, my y value is 0. So I have these two little points that I'm sort of concerned about. I need to get rid of those from the domain. So in order to determine the domain of g divided by f, what we're going to do is we are going to look, or rather, the domain of g divided by f is the intersection of the domains of the original ones, and then we have to exclude any values of x that make that make f equal to 0. So we said that the intersection of the two previous ones was just 3,9. So 3,9, but then I have to get rid of 6 and I have to get rid of 8. So then think about that. Let's see if we can do this graphically. So we have said that the overlap is from 3 to 9. That's the overlap of the two original domains. But now I have to further get rid of the value 6. That should be right there in the middle. And the value 8. So I have to get rid of 6. And I have to get rid of 8. Okay, and so then my domain becomes, well, everything. So now if you think about it, it's made up of 3 pieces, from 3 to 6, the values between 6 and 8, and values from 8 to 9. And the open circles would have to correspond to parentheses. So my domain is going to start looking like this now. 3 to 6, parentheses, union, 6 to 8, parentheses, union, 8 to 9 with a bracket. This one's a little tricky. Think about what happened here. The domain of f divided by g is going to be equal to the intersection, the overlap of the original domains. Well, that's kind of like this thing that we did earlier. But then we have to get rid of any values of x that make the denominator 0. Well, these were the two values of x that make the denominator 0, 6 and 8. So we have to get rid of those. Okay, so hopefully we agree on the answers here. And this idea of determining domain of these new functions is a little bit better. Let's get into a different little topic here. This thing called the difference quotient. And that's the last part for this section here. So this difference quotient, you're going to be using it quite a bit in Calc 1. Calc 1 starts right off the bat with this thing of a difference quotient. And what we need to just kind of know how to simplify it. This difference quotient, what it is just slope. Think about this as slope. And let me just kind of sketch a little picture here for you. You don't need to know anything about this picture. I just kind of want to mention it so that you don't think that you get an idea where this little formula comes from. So imagine that I had a little value x right here, and then I'm going to say that this over here is x plus h. What that means is that this little length right here was h. And I don't know, imagine that we have some function. I don't know, let's use something like this. So I have a point there, I have a point there. Here the y coordinate, since this is x, the y coordinate right here is going to be f of x, and then the y coordinate up here should be f of x plus h. And so that's what's going on right now. I have a point. The coordinates of this little point, the coordinate of that point is x, comma, f of x. That's its coordinates. The coordinate of this point up here is x plus h, comma, f of x plus h. Okay? And now imagine that we draw a line that joins those 2 points, a straight line, because this is a curve. Now imagine a straight line that goes through those 2 points. Yeah? This is called a secant line. So I have what's called a secant line. And then if I think of the slope of the secant line, so imagine I wanted to find the slope of this little black line right here that joins these 2 points. Well, we know how to find the slope. The slope would say this. It would say f of x plus h minus f of x, because that would be the difference in the y's. So f of x plus h minus f of x. Remember, here the y coordinate would be f of x plus h divided by x plus h. So now the difference in the x's minus x. And that's how we end up with this little formula right here. That's how we end up with what's called the difference quotient. The difference quotient is just the slope of a secant line. And you'll get the opportunity to work a lot with this once you get to Calc 1. But just think about it, all it is just truly is just the slope of a line. It's just the slope of a line. That's what this difference quotient is. All right, so let's get into these exercises then. Right now, what we need to do is simplify the difference quotient for some functions. And there's some algebra involved. There's a little bit of symbology involved. So let's see, they give us some steps. The first thing is to find f of x plus h. And then we're going to have to plug it into this thing called the difference quotient. And you do not need to memorize this. It'll be given to you. So then you plug it into this little formula. You distribute this negative into f of x. Simplify as much as you can. And that's it. Sounds simple, right? But the devil's in the details. Simplifying things sometimes is very difficult. It's difficult to simplify, I guess, is the moral. All right, so I'm gonna help you with one. I'll help you with the first one, and then you'll try the next one on your own. Let's see. So I gotta simplify the difference quotient here. I gotta form and simplify the difference quotient for the part A. So the first thing I'm going to do is figure out what is f of x plus h. Okay. So what does f of x plus h mean? It means anywhere where you have x's in your original function, you're going to replace the x with x plus h. That's all it means. So it's going to look like this. 3, and I'm going to open a parenthesis now. Just think about x as a little container. And this is the input. The thing that's in this parenthesis is the input. It's what replaces that container, or what goes into that container. So I'm being careful here to put a parenthesis. So then this says 3x plus h plus 2. And well, yeah, I can definitely distribute the 3. And that is what f of x plus h is. Okay, so think about the difference quotient. It's up here. Right now what we have computed is just this little part, f of x plus h, the left part. So let me write it down here. So I have f of x plus h minus f of x over h. All right, so I have computed and simplified this part right here so far. That's the only thing I've done. That's the work that I did here. So let me start replacing things. So this is going to say 3x plus 3h plus 2 minus, so there's this minus right here, that's right there, and then I'm going to put a parenthesis here. And then, well, f of x is just the original function, 3x plus 2. So 3x plus 2, and all of this divided by h. Yeah, so I have formed, at this point I have formed the difference quotient. It's formed. What's not quite finished yet is the simplification. Now I gotta simplify this. Okay, so I gotta distribute this negative. This negative should apply to this 3x and to this 2. So it looks like this, 3x plus 3h plus 2 minus 3x minus 2, and all of this divided by h. And if you did this correctly, what ends up happening is that all the things with x or x squared, all the constants sort of cancel each other out, and only the things that have h remain. Things with h, or maybe x times h, or maybe x squared times h, but they should have h involved. Okay, so we're almost done. So now I just have that this becomes 3h over h. Yeah? And this h's cancel. And my answer, I suppose, is just 3. That's the simplified difference quotient for this particular function. All right, so now it's your turn. Pause the video, form and simplify the difference quotient for this other function right here. This one's a little bit more involved because there's x squared, but I know that you can do it, so take a minute, try to do it. Let's compare answers afterwards. Okay, so hopefully you have the simplified form of this difference quotient. Let's see, let's just compare answers. We should get the same thing, right? Let me begin by forming f of x plus h. Well, okay, so it's going to be x plus h squared minus 3. So all I had to do was replace my x with x plus h. Now let me expand this a little bit. I have to do x plus h times x plus h. That's what x plus h squared means. So there's some foiling that has to happen here. It's going to be x times x times h times x, and h times h. So that becomes this, x squared plus xh plus hx plus h squared. Yeah? And x times h and h times x turns out is the same thing. It's like saying 2 times 3 is the same thing as 3 times 2. So there's 2 of these ones. So then the simplified form here looks something like this. X squared plus 2xh plus h squared. And then let me not forget minus 3. Yeah? So far all I've done is figure out what is f of x plus h. So I replace my x with x plus h. Alright, I got this weird looking expression here now. Now let me plug things into the difference quotient. So I'm going to have this f of x plus h minus f of x divided by h. So far I know this piece right here, this left part. That's what I computed up here. So I know this left part. The other things are not too difficult. I mean, f of x was just given to us. F of x is just the original function. You just gotta be careful with that minus. So let me put everything together. X squared plus 2xh plus h squared minus 3. That is just this part right here, f of x plus h. And then minus, I'm gonna open up parentheses. The function f of x is x squared minus 3. All of this divided by h. Okay, now I gotta distribute this negative right here. This negative applies to that and that. So this is going to look like this. Notice that this negative made the x squared negative and made the 3 positive. Okay, and now if everything went correctly, all sorts of things should cancel for you. X squared cancels with x squared, negative 3 cancels with positive 3. Yeah, and I end up with this. 2xh plus h squared divided by h. And we're almost done here. Now what needs to happen is that in the numerator, you see in the numerator I have 2 terms. Both of them have h, so I can factor out an h from both of them. So that step looks like this. h 2x plus h over h. So what I did is some factoring in the numerator. Since these 2 terms had an h in common, I factored it out. That's why it's outside of this parenthesis here. If I was to multiply it back, I'd just get back here. And now what happens is that, well, this h in the numerator and this h in the denominator cancel. And my simplified form is just 2x plus h. That is the simplified difference quotient for that last example there. Okay, I hope that we agree and that you find this process simple. It definitely gets harder depending on the functions that were given to you originally. And again, this is going to be what you're going to be doing in Calc 1 quite a bit at the beginning of Calc 1. So not a bad thing to kind of already get used to. Okay, so that's it for this video. I'll see you in the next section. Thank you.